For covalent bonding, when we go to draw and find all the shapes, we're going to find that covalent bonds are again between shared electrons of two nonmetals. These do form molecules and therefore are non-electrolytes. In order to find the number of bonds, we're going to be using what's called happy actual math. So the happy amount is the number of atoms we have times the amount of valence electrons it takes to be happy. The A, or the actual, is the number of atoms times valence electrons on your periodic table. When we take a look for the happy amount, remember the valence electrons on the table, if it's less than 4, you double. If it's greater or equal to 4, you're going to use what's called the octet. Basically double up to 8. So we're going to take a look at water and see how this works together. So for water, we have our happy and we have our actual. With our happy amount, I have 2 hydrogen with 1 oxygen. So taking a look here, I'm going to put a 2 for my hydrogen. On the periodic table, valence electron amount for hydrogen is 1. Since that amount is less than 4, then I'm going to simply double the amount that I have. I have 1 valence electrons, 1 doubled is 2. Now we're going to move on to the oxygen. There is 1 oxygen present. On our valence electron periodic table, we can find that there are 6 valence electrons. 6 is actually greater than my 4, so therefore I'm going to use the 8 to make it happy. So on the top, we put our 8. And then we are going to tally these up. I end up with 12 on the top, 8 on the bottom. Subtract these two numbers to tell me how many electrons I'm going to be using in bonding. We're going to divide by 2 because 2 electrons make a bond. And with those 2 electrons making a bond, that means I'm going to end up with 2 bonds. So bringing my elements over to draw this out, I have hydrogen. It has 1 dot because there's 1 valence electron. Oxygen is going to have 6 dots to represent the 6 valence electrons. And we get that right back here on my actuals. Wherever there are single dots, we can connect them, drawing a line, and that makes a bond. Notice hydrogen now has 2 electrons in that bond. That's how many it needed to be happy. So it is a happy hydrogen. Oxygen is not quite so lucky yet. It still has a single one at the bottom. But notice in our formula, I do have 2 hydrogens. We're going to draw the second one in, connect the dots, and now hydrogen, the second one, is happy as well. And oxygen now has 2, 4, 6, 8. 8 valence electrons means it is happy as well. And we have just drawn our water. Now, when we look at our water, we want to be able to find its shape. To find the shape, we are going to use our molecular geometry chart, and we are going to take a look at the steric number. So you want to make sure this chart is handy, and then we need to look at what makes up steric numbers. For our steric number, it's simply the region where we have our electrons around the center. It can be represented by a single bond, double bond, triple bond, or unshared pair. Remember, single bonds are weak, but they are long. Triple bonds are our strongest bond, but they are short. And the unshared pair are the strongest of all of our steric number examples. Now, taking a look at our water, if we take a look at this, you want to always analyze the center atom. In this case, my center atom is going to be the oxygen. So, looking at this, how many atoms are bound to the center? We have 2 hydrogen. So my Ba, or bonded atoms, is 2. Looking at the oxygen with our unshared pair, that's these dots that are not involved in a line, those are 2. And remember, you only care about them if they're on the center atom. If they're on the other atoms, you ignore them. So on the center atom, I have 2 unshared pair. So that is going to give me a steric number of 4 when I add them together. Now take a look here. On our sheet, for my steric number, I go down to 4. Number of bonded atoms, I'm going to go to 2. Unshared pair of electrons, down to 2. The answer for my shape, water is going to make a bent shape. So this is actually called bent. And that is how you complete a covalent bond, from finding the number of bonds to drawing the Lewis dot diagram to finding its shape. And remember, covalent bonds are shared electrons between the 2 nonmetals.